I would like to follow that path, and I would like to give you a few numbers, a few examples, and then I would like to see the different problems and opportunities beyond that world of big data, and also challenges and opportunities, as we saw before. To start with, I have a few numbers from that report, which is not so different from the other reports, but it is one of the last ones for September 2016. And you have a lot of reports everywhere, but anyway, this has been done from Epson. It's interesting about the trends. So, a few ideas here. As my colleague said, giving some numbers before getting into details of the examples. So, look at those numbers indicated here. Growth as far as the connected objects are concerned, not laptops, not mobile phones, not computers. As you see it here, we are dealing with growth which is higher than the one we're used to in more traditional devices. So how is that use growing? What is the impact? That graph here is important. You can see the curve here. It is the voice traffic. Traditional phone calls, and it's totally different. Now we use data. Everything is linked to bytes, which are given, even videos and even voices. And if you go and see where is the traffic focused on, you see the space, you see the networks, social networks, you see the interactions that we have, and those data are fundamental for our discussion. We can see how it is changing concretely today, the scenario of the digital technology. It will change more and more, and we can see how it is evolving and how the durable devices are evolving. We are using the swatches, trackers, and different things. But we are also getting to systems which will feel the emotions and also communications of, gestures and races or allergies. That means, that at the end of the day, as the colleague said, we need to put data all together which are exploding. This is another chat which is very interesting. We are always, able to deal with those elements. 54% of the persons are available to give their data to the builders, to the doctors, to and companies of insurance, and at the end of the day, not to our employers. So it means that we are very worried about privacy, but then we're very orientated to divide it, to share it with some actors. Specific actors, anyway. So I could continue for hours and take like 300 reports, but all that information is in the same direction. We are creating a quantity of information which is always more and more massive, with growth rates which are very important, and that is for sure, and that will continue, in the future to cannibalize, our mentalities. So I would like to give you some example here and there to be clear, and I think that really it's clear to see the pervasion and the diffusion of that revolution. This is a project we have been doing for a manufacturer of jackets for biking, motor biking, typical made in Italy company. for leather manufacturing. And they have sensors on the motorbike which are wireless connected with the jacket of the biker, and then each 15 milliseconds they decide if you have an alarm situation and possible accident, and within 45 milliseconds they then put the airbag functioning. So everything is linked on the motorbike, but mainly on the jacket. And it is a producer of jackets, not Apple, which did that. It is a typical SME, Italian SME. So then we have data collected in real time here, and they give the situation of the bike in real time to the whole system and potentially to the whole world, like the insurances, the alarm systems, and these kind of things. So we have sensors. Well, this is not fantasy. This is truth. It is real. So they are objects which are changing the classical made in Italy production, for example. But we also have simple things. A few days ago, we had this on a newspaper. In a smart world, you're full of those elements in the dustbin, so you can really also use a bin for that. So incredible challenge is to keep that, to have low cost, to see if the bin is empty or full, or also to see what is inside. Why not? To see if you have a cellular phone inside, for example, so it must be efficient, but it must also be there for 1 year time without being refilled. So advantages are quite clear. Optimizing research, giving a clear aspect to the citizen and a clear vision for the future, and how we can, enter in that process and see how we can clean the city, clean the places in general. So, do we have something simpler than a dustbin? Well, technology, of course, data, and another case, because we wanted to put together this kind of dispenser, we had humidity and temperature sensor. So, in fact, we created like a station, a weather station, putting those devices in all the towns. We collected data, in fact. So those technologies actually interact with the common objects. So it's €1, 100 euros, but it becomes smart, gives more quality, and improves the process. So everything happens in all the fields. So we could spend so much time seeing what happens. The project had started a few days ago, and some criticized the Italian research, but we have very few institutes in Europe, but actually we use database and data-driven genomic computing. It is a project starting now to study through the use of systems of analysis, data analysis, everything which is related to DNA and diseases, genomes, and so on. So a lot of research of in the long run. So we also want to see all those data on our smartphones, and we want to collect any kind of information. And in the morning I can weight myself and see what is my weight, and with those objects they can tell me, well, you're not tranquil, you're stressed, or whatever. So this is really, a clear-cut vision of our daily life. And we can use it. So the decision-making process is changing in that review. So I can really take decisions in my companies in a different way. In fact, we can see turnover or sales and see what happens, that I have an update, and I can know what is possible in that decision-making process in real time every day, thanks to the use of those techniques. So, well, yes, we have a lot of other fields of applications, and I wanted here to show you that app. I don't know if you know it. So who is actually flying in Europe? This is in real-time data collection. New York, Copenhagen, Boeing, which is flying here in real time. Look at all the data here in real time. It is huge. You have all the planes, data collection, and this is one of the most famous one for, let's see who is flying over our heads. So we are here at the moment. We have a Lyon, Venice, which is landing now. Actually, another one has just taken off. But anyway, this is exactly our world. Any kind of object produces data which can be collected, distributed, and handled with the different apps. So you can see the different fields, as we saw before, different fields where you have those apps developed. So now, what are the drivers? Some more words on the drivers. Well, the challenges first. Well, you have more or less those. Each kind of object can generate information. I can see the potentiality of calculation, so I can work on that, generate information, generate data. We have IoT. We have also, we heard the colleague yesterday dealing, with all the persons creating data. So objects and persons creating, generating data with a smartphone or chip or sensor. And second aspect, the costs will continue decreasing. So we'll have systems which are more and more powerful. So my smartphone is more powerful than the one I used at the Polytechnical School, because I was in a room like this one. And third point, this is quite impressive, and I try to repeat it using words. Any kind of object and part of the planet can be connected to the internet. Any kind of object and point and environment can be connected. So if you're in the middle of the ocean, you can be connected. So there's no place where you cannot be connected. It doesn't exist. And also, with our softwares, we do everything. Hardware without software, it is nonsense. Nothing can be done. Software gives intelligence. And now we can have very sophisticated softwares with those techniques, and we have developed such incredible things. And persons are involved in that sense. So we all generate, data, and these are the driving forces. And we also work with cloud computing, and we can put a lot of resources which are interconnected, and we can use them properly. So these are the driving forces. Then what are exactly the big data? I do not want to be, too theoric, but a few hints here, because we deal with the different ways. Big data means you have great volumes, petabyte, terabytes, so huge quantity of data. Then multimedia, of course, video, voice, non-structured. that would change the speed. So very high traffic on the social networks, and that will vary in the in the framework. And a lot of apps that we do are not big data, because we do tend actually to not have those sets, and here are a few examples. Beyond big data, you have the real big data, so analysis in real time of social network flaws and social of a company, but also a lot of analysis which can be done with very limited things using the same techniques, or nearly the same techniques. There is, a sense which has been changed actually, but has a different thing that we use daily. So an example, we have been working for a company, and the problem was to improve the esteem or the evaluation of accidents. So actually, they had internal data with external data, and that was really interesting, and different kind of things, and evaluation of the risk, and also in a very precise way. So actually we have 5 gigabytes of data, and that was quite incredible for big data. So we have a statistics analysis, very sophisticated, of integration of data, which is totally complex, and it's not big data, it is limited. Velocity is very low, as we say, but we have that world of generation, of elaboration of information. Another example, we have made an app with Pirelli company to take in real time data for motorbiking. And in fact, you will see here a few examples. This is an app on the smartphone, and then you can collect data about the behavior, to see how the driver is behaving, and what is the situation. So you can download it. I do not want to lose time here, but yes. So there are not so many, data, because these are the data you have on the smartphone. So what is interesting, you have a lot of sophisticated data that you can collect with a telephone. A telephone is not only for calling, it is to speed up GPS, to have different techniques which are very interesting. So those objects are not very well are not sophisticated to make calculation on the asset, but then we can have algorithms which are very specific, can study in details the behavior of a wheel of a motorbike. And I can do it on a telephone, on a mobile phone. You can buy in a store. It's not so sophisticated, and data are not so wide. They are on the phone. So big data is a term which is very wide, and then is applied to different situations, and methodologies also can be applied in different ways, even in different ways. Now, what about the magic box syndrome? This is one of the risks. We have a lot of young people here. Big data doesn't mean you have a magic box with numbers and, data, so you have all of a sudden all the answers you need. It doesn't exist. What does exist is that you have models which can be created by persons and that can allow us to analyze and study the information and knowledge of data. It means that you have a very big role of persons and data scientists, experts, and we are building our methods to interpret data. There's no magic box which gives us the answers, It doesn't exist. So there's no magic here. It's only a lot of work, a lot of knowledge, a lot of study. And then, second part, we have seen the privacy aspect and all those data. How are they used, actually? Well, there are no short ways. We have very complex path. On the one way, we must protect people, and one of our colleagues is making an incredible work. He's a philosopher from Oxford, and is, explaining what is privacy in digital era. It's totally different. We must protect people, but also we must protect freedom of press and history. And you cannot cancel all news on Hitler because his family wants to have different rights and so on. Is possible to forget? Is the right of, to forget possible? No. So we cannot, how can we, how is it possible to cancel memories, and when shall we cancel the memory? Because, memory is very important for our society. So how is privacy, defined? How is privacy interacting with all this? It is very complex. It's not only a question of opinions. Privacy, rights, and then right to forget, what is the feasibility of that? Is that possible to put different kind of techniques together? And in which cases shall we do it? In what other cases shall we avoid them? So you see, some states want to create rules, cyber ruling, for example, to see the problem and to understand where is the real problem on cyber terrorism, for example. And often we think that intelligence and automation are the same. Industrial robots are not intelligent. They are machines. They make standards movements to create a car, but they're not intelligent. It is different if the robot goes to hospital to assist, to assist people, interacting with people, having, delicacy as a nurse or a doctor. This is totally different. So the robots working in a factory, like we have, some companies have a lot of robots, and having them in a hospital or in a factory, it is in a site, it is totally different. This is not the same kind of robot, of course. So we are still in that debate, and when we deal with automation and intelligence, we deal with different concepts. We are very good in automation. Intelligence in the sense of interaction, of human interaction. And then we deal with technological singularity, because we'll build objects which are connected, and the speed of elaboration and then the use of data, so big data, they will become intelligent. But I'm skeptic. I'm very, very skeptic about speed and data together. I'm very skeptic. Because I don't know, Alan Turing movie, well, beyond what he's done in the film, at the end you can see that he's created the model, identified as computer, model. So, and then some things can be criticized, other cannot. So it depends, according to the functions of the computer, well, you can define some things and the speed and the capacity and so on. So the problem was not possible to be implemented on a computer. So you have limits, very clear limits, which have not been overcome yet. So we still have machines which work according to certain paradigm. So this is what, as I say, well, I have doubts, a lot of doubts, and we'll have very, very precise systems, very quick, very fast systems. But you see, Stanford study done by a series of teachers in the States is very interesting. Contrary to the more fantastic prediction for the popular press, the study panel found no cause for concern that the AI is a threat to humankind. No machine with such sustaining goals and intents have been developed, nor are they likely to be developed in the future. We are not creating artificial intelligence. We're not. We are all intelligent as human beings, and very efficient as well. So this is the point. I like that topic because we can put any kind of data, and this is always the same thing. So what are the challenges? I have 5 more minutes, so I must speed up. Anyway, challenges. First, the technological ones are not the most important. Safety and security are the first, as we said before. Then let's think of the airbag I showed you before. It must be first safe. Safe means it cannot open if there's no risk. So we've made certificates in Germany. The first rule for the certificate is to have really not increasing the risks of the person. So if I'm driving and the airbag is being, is opening without any problem, I am exposed to a risk and I could die. So these systems must be simple, but then secure, safe. So we've made tests with the different bikes and on the roads. So sensors on a bike at a certain point must control, and you can have accidents. This is wireless airbag system through the jacket, as we said before. So how shall we handle this one? Through a SIM, authentication, and then I send a signal to the right jacket, not the others. So if then you want to, be hazardous, make an attack, or be harmful, what happens? These are the examples very clear. We must wonder about that, and this is quite, tricky. So I could create a breach in the communication. So these themes are fundamental. And then ICT. ICT, the more it is pervasive, the more it is potentially subjected to dangers and threats linked to security. Another topic, which is really fundamental, is data meaning. What does data means? I always give a stupid example here. If I tell you that the temperature of the room is 40 degrees, you think that it is 40 degrees Celsius, but I could 40 degrees Fahrenheit. Yes, it is 40 degrees Celsius, but it is if it is Fahrenheit, it's freezing. So how shall we interpret those data? So interpreting data is fundamental. What does it mean? What does numbers mean? What does data mean? How do we study data, and how do we extract information and dwell on information? from the sensors. So how shall we assess the quality? 40 degrees, because I have the opportunity to measure it, or because I'm telling it, according to me, it's hot today, so 40 degrees. They're totally two different things. So, what do we mean by quality? Precision? Of course, being precise? Yes. The point here is how to interpret data, how to analyze it. It is very complex. And this is connected as well to two other questions: the standards and interoperability. How shall we exchange those data? So we have the hub taking infos on planes, on all different brands and different companies. Well, you have the same way of collecting data. British Airways or Boeing or Alitalia and Air France have the same system. You collect it the same way. So this is the standardization and interoperability. So then you need to have a systemic action, like GSM had a great success because you have all the players together gathering that information. So is it possible to use those data all together? Now I need to conclude. So 2 more minutes. You can go and see those slides on the expo. Anyway, privacy aspect is very interesting. What is the scope boundary of a person? Where is the end of the person? The information is all over the world, on the planet, but to deal with privacy, how shall we define who I am as an individual? The professor is discussing on different aspects, and we had a beautiful presentation in Florence on human dignity, and the problem is to protect personal ID. This is a technical problem. What is the definition of my person, my personality? Where's the end of my person? What does that mean to protect my identity? These are all challenges which we have not answered yet. And one of the main challenges is education and training. And I do not believe in digital native. This is my last slide. So, why do I not believe in that? I've seen it with my family, with my children, and I am a teacher at university. I see people, young people of 18 years old, we do mix the capacity, manual, operational one, with education to use digital tools. It is totally different. A lot of the problems we have seen those years, generating in youngsters using in a poor way the social networks, probably they're excellent. They're very good at, using their mobile phones, but you have a lack of digital culture, a lack of consciousness of a social network, how it works, the internet works, what are the rules of safety, without getting into details. So we do mix the capacity, manual capacity, with the education to that digitalization. And then this is the basis, because we all need that knowledge, that technique, that know-how. Then you can, of course, have experts, but this education of basis education is lacking, and this is really a problem, an issue which has a direct impact of big data evolution. So we do generate data and distribute them, so we must be aware that young people should know how to use data. And this is probably the biggest challenge that we have this morning, and we need to build a new citizen which is digital citizen, because we do not have analogical and digital world, and our life is digital, so per default. So it means that we need to have a different way of building citizenship. It must be part of our citizenship to understand what is a user of those technologies. So I think we have a lot of challenges. Right, in 30 minutes, I only try to give you a few ideas. Thank you for your attention.